Hey guys, welcome back to week 3. This week we are going to be talking about compound probability. So you've probably already talked about compound probability before, but what we're going to be really focusing in on is the difference between independent and dependent events. So what I mean by that, there are two types of compound events. These are independent and dependent events. So as you can see, independent events are two or more events that have no effect on one another. So what I mean by that, if I were to roll a dice and then spin a spinner, I would have no effect on one another. So if I were to roll a dice, maybe I'd roll a 6 and then spin a colored spinner and get a red. Those 6 and that red did not have an effect on one another. Now, a dependent event is an event that does have an effect on one another. So for instance, I've got a bag here with some marbles, and we'll say this one's red, and maybe this one's yellow. And I'm going to go in there, I'm going to reach in the bag, and I'm going to pick out a red marble. Well, once that red marble is no longer in the bag, the probability of picking a second red marble is going to change. There were 2 out of 3 in the bag. Well, now there's only 1 out of 2 in the bag. So that dependent is going to change our probability slightly. All right, so some keywords to know which one, when it's independent and when it's dependent. An independent event is when we use this word replacement. Now, I'm going to use a colored pen here to highlight this word replacement. If they do tell us to replace something, that's a good indicator that it is an independent event. We're looking for words like put it back, start over, replace the item, things like that. In a dependent event, you're going to see this without replacement. That means do not put it back, kind of like this marble situation. If they said put the marble back, then we would be talking about independent events, but because they did not tell us to put the marble back, the marble is no longer in the bag, that's going to be dependent events. They may say things like do not put it back, put the item in your pocket, all kinds of things. Sometimes they won't say anything at all, and they're not going to give you any clues. You're going to have to think about the situation and think about what they're asking you. For instance, if 2 people are chosen at random, that would be dependent because it wouldn't make sense to choose the same person twice. In a classroom, if a teacher says, okay, I need 2 helpers, they wouldn't pick Susie Sunshine twice. They would pick 2 different people, so that would be dependent. If I were rolling 2 different dice, they're not going to have an effect on one another. I could roll a 6 and then a 6 again, no effect. It's going to be independent. All right, so here are going to be our steps for finding probability, the 2 different types of probability. But I'm going to scoot down here to our practice problems so that way we can get to learning through practice. All right, so 2 fair coins are flipped at the same time. What is the probability that both display tails? So first we need to determine if it is independent or dependent probability. So did they tell us that these 2, we're going to pick one and then have to put one back? No, there's not really those words. We just talked about all these words and then this problem doesn't use it. But let's think about 2 coins. Maybe I'm going to drop 2 quarters. Is the result of one quarter going to affect the other quarter? No. So this would be independent probability because these 2 events do not affect one another. Yeah, they might bump into each other, but that's not going to say, oh, well, this one's a head, so this one can't be heads. Nothing like that. So those probabilities are not going to affect each other. So the way that we're going to calculate probability, we first need to remember that the way we find probability is going to be the number of favorable outcomes. So what we are hoping will happen. So the number of favorable outcomes over the total number of outcomes. So let's go ahead and talk about that with these 2 coins. When we are looking for them to display tails, so we're going to separate our workspace into 2 sections. This is event number 1 and event number 2. All right, so for our first event, how many sides of a coin display tails? Think about like a quarter. Maybe you've got one in your pocket you can look at. When we look at a quarter, there are 2 sides to a coin. There are 2 sides to a coin. So the total number of possible outcomes is 2. We can either have a coin show us heads or tails. Not both, not an in-between, just 2 options, heads or tails. Of those two total options, how many sides show tails? Now, in a true fair coin, you're only going to have one side that shows tails. All right, so let's talk about the second situation. Did one coin affect the other? Did we have anything change? No, so we're still going to have the probability be 1/2. This is one coin being flipped has a probability of 1/2. The second coin being flipped has a probability of 1/2. Now that we know the probability of each separate event, we're going to go ahead and multiply those two events. So we're going to do top times top, bottom times bottom, just like any old fraction. So 1 times 1 is 1, and 2 times 2 is 4. Now don't forget, you can always write probability as a decimal, so it'd be 0.25, or you can think about it as a fraction being 25%. I didn't mean to write that 0 there. However, for today, we're going to be using fractions most commonly. Most of our problems this week are going to be in the form of a fraction. All right, so problem number 2. A box contains 9 light bulbs and 6 used light bulbs. Each light bulb is the same size and shape. Meredith will randomly select 2 light bulbs from the box without replacement. As soon as I see that word without replacement, I like to box it in my color, and I'm going to go ahead and write that this is a dependent event. Just like we talked about up above, when you see those words without replacement, you know it is dependent. So what is the probability that Meredith will select a new light bulb and then a used light bulb? So let's talk about those new light bulbs first. So we've got our workspace over here off to the side, and I'm going to separate it into 2 sections. Event number 1, event number 2. All right, so for event number 1, how many light bulbs are new light bulbs? They told us in the beginning that there are 9 new light bulbs. So there are 9 favorable outcomes. But we need to figure out the total number of outcomes. So we're going to have to do some addition. If there were 9 light bulbs, 9 new ones, plus 6 used ones, how many light bulbs are in this box? So 9 plus 6 is going to give us 15 total light bulbs. So our first probability is going to be 9 over 15. The second situation, now we've taken one light bulb out. How many light bulbs are still in the box? If there were 15, we just removed 1. We have a total of 14 light bulbs in the box. So our second situation, we're going to put a 14 on the bottom because now there are only 14 light bulbs in that box. All right, so let's talk about the number on the top. We are looking for used light bulbs. Do we need to change the number of used light bulbs in the box? No, nothing happened to the 6 used light bulbs. There are still 6 used light bulbs. So what we're going to do is we're going to do 9 times 6 and 15 times 14. So 9 times 6 is going to give me 54. 15 times 14, that's going to give me 210. Now, the way that I like to simplify fractions is I cut them in half. So I'm going to divide by 2 and get 27 over 105. And that's not quite simplified, but I can't simplify by by 2s. So I'm going to have to simplify by 3s. I'm going to divide by 3. So 27 divided by 3 is 9. And then 105 divided by 3 is 35. Now, I'm not going to lie to you. I totally used a calculator for that, and you can too. All right, so let's talk about problem number 3. Cynthia has 14 roses in a vase, and then they tell us what kind of roses she has. She is randomly going to select 2 roses from the vase with no replacement. Again, I see that word, no replacement. So right at the top of the problem, I'm going to go ahead and write that this is a dependent event. What is the probability that Cynthia will select a red rose and then a pink rose? All right, so let's separate our workspace. We're looking at 2 events, number 1 and number 2. All right, so first let's figure out how many total outcomes there are. They told us that there are 14 roses in the vase, so we're going to put a 14 on the bottom. So in situation 1, she's going to pick a red rose. How many red roses are in the vase? 4. So we're going to write 4 over 14. Second situation, I've picked a rose. I'm moving on to pick the second rose. How many roses are in the vase now? If I had 14 and I removed 1, now I have 13 roses in the vase. So on the bottom, I've got a 13. Remember, when it's dependent, you're going to have some different numbers there on the bottom. Independent, you'll have that same number on the bottom. All right, so let's talk about it. How many pink roses are there? Did we remove any pink roses? No, so we're going to continue with that 5 pink roses. So I'm going to do some multiplying. Top times top, 4 times 5 is going to give me 20. 14 times 13 is going to give me 182. And again, I'm going to cut that in half to get 10 over 91. And I can't simplify that any further, so I am done at 10 over 91. Sometimes your fractions aren't going to simplify too much. Just get them as simplified as you can. All right, let's talk about number 4. Remember, if I'm going too quickly or you want to stop and practice, you're absolutely able to pause my video, rewind it, go back and rewatch something. It's totally up to you. I would definitely recommend that you pause the video here and try 4, 5, and 6 by yourself, or you can watch one more problem and follow along with me before you practice by yourself. Problem number 4. Eric and Sue will randomly select from a treat bag containing 6 lollipops and 4 gumballs. Eric is going to select a treat, replace it, box that word, replace it, and then select a second treat. That means we're talking about independent probability. Sue, on the other hand, will select a treat, not replace it, and then select a second treat. We're going to talk about dependent because she is not replacing her treat. Calculate the probability of each and determine who has the greater. All right, so I'm going to cut my work here in 2 like that. And the top is going to be Eric. I'm going to just draw a line here to keep myself straight. And the bottom down here will be Sue. All right, so Eric has 2 things happening. He's going to first pick from the bag. There were 6 lollipops and 4 gumballs. So there were 10 total pieces of candy. He's going to try and pick 1 lollipop. There are 6 lollipops to start, so 6 out of 10. He is replacing it. That means he's putting it back. It's independent. So that means my number on the bottom is going to be the same. And since he put that first lollipop back, we know that he wants 1 gumball. So we're going to go with the 4 gumballs that we started with. So when we multiply, we're going to do 6 times 4 and 10 times 10. So 6 times 4, I'm going to just write it over here. Gives me 24 over 100. I'm going to cut that in half and get 12 over 50. Cut it in half again and get 6 over 25. So Eric has a 6 out of 25 chance of getting a lollipop and then a gumball. Let's talk about Sue. So Sue is going to grab a lollipop. There are 6 lollipops out of 10 pieces of candy in the bag to start. So that first probability, totally the same. Here's where it changes. When she doesn't put back that lollipop, that means there's 1 less piece of candy in the bag. So there's no longer 10 pieces of candy. Now there's 9 pieces of candy. A little bit different. Did she take any of the gumballs? No. So we still have 4 gumballs. So what I'm going to go ahead and do is multiply like I did with Eric. 6 times 4 also gave me 24. 10 times 9 this time is going to give me 90. Now I'm going to go ahead and simplify that by cutting it in half again. And I'm going to get 12 over 45. I can't cut 45 in half, but I can divide it by 3. I can also divide 12 by 3, so I'm going to get 4 over 15. So I've got my 2 simplified fractions. But the question is, which one of them is greater? So the easy way to figure this out, I'm going to go ahead and use my calculator. And I'm going to divide these 2 and get 6 divided by 25 and get a decimal of 0.24. Again, I'm going to divide this side, 4 divided by 15. And I'm going to get 0.266 repeating. which one of those two numbers is larger? Would you rather have 24 cents or 0.266 repeating cents? You're definitely going to want this one, so Sue is the greater probability. But we can definitely see how things change just by putting that piece of candy back. If you haven't already tried to pause, go ahead and try and pause, and we're going to do 5 and 6 by ourselves. Hopefully you paused and you do already have at least number 5 done, if not number 6 as well. Let's go ahead and talk about them. A bag contained 6 red marbles, 8 blue marbles, and 6 white marbles. If one marble is selected at random from the bag and is not replaced, what is the probability that it will be blue and then blue again? Excuse me. So first we got to figure out how many marbles are in the bag. We had 6 plus 8 plus 6. That's going to give us a total of 20 marbles in the bag. All right, so I know there are a total of 20. I'm going to cut my workspace into situation 1 and situation 2. All right, so there were 8 blue marbles in the bag out of 20. That first one's always the easier one. Situation 2, did they tell us to put the marble back? They did not. They said not replaced. So that means this is dependent. And because it's dependent, that means I am going to be using the subtraction. So I had 20 marbles in the bag. I took 1 marble out of the bag. So that means it's no longer 20. There are 19 marbles in the bag. So now that I know there were only 19 marbles in the bag the second time, now I can figure out how many of them were blue. They told us there were 8 blue. We just picked one out in the first situation, so now there are only 7 blue marbles. Make sure you read the directions carefully because sometimes it's not going to just affect the bottom, it's also going to affect the top as well. So I'm going to go ahead and do 8 times 7, get that number of 56, 20 times 19, and I'm going to get 380, big number. To simplify, I'm going to go ahead and cut that in half, and I'm going to get 28 over 190. I'm going to cut that in half again and get 14 over 95. Now, I am not going to lie to you. I totally used the calculator for that. I just had the answers over here. You are absolutely allowed to use a calculator for this unit. Please, please, please feel free to do so. All right, so our final answer is going to be that 14 over 95. That is our probability for situation number 5. Again, remember when to subtract the top because we picked blue and then blue again, or not to subtract the top when we're picking 2 different things. Let's talk about problem number 6. There are 8 brownies and 4 cookies. Each student may have 1 dessert. You choose one, then the next person picks one. What type of event is this, and what is the probability of the event occurring? All right, so if I pick a dessert and then you pick a dessert, does it make sense for us to both have the same dessert? We may both pick brownies, but we're each going to pick a separate plate of brownies. We're not going to eat the same brownies. So this is going to be dependent because what I pick, my dessert, is going to affect the outcome of your dessert. If I pick a brownie, there's going to be 1 less brownie for you to randomly choose. All right, so we're going to go ahead and do our 2 situation little section here. The first one, when I pick the dessert, there's going to be 8 brownies and 4 cookies. So we're going to do 8 plus 4. Gives us 12 possible outcomes. So we're going to put a 12 on the bottom. So if I were to pick, this problem doesn't quite say. So let's say we're determining the probability of brownies. I think they messed up there. So there are 8 brownies to choose from. If I want to know you picking the same dessert of brownies again, how many brownies are there? If I already picked one, 1 is removed. So we're going to do 8 minus 1 and get a 7 on the top. Now on the bottom, we had 12 outcomes. We removed one of them. So now it's 11 outcomes. Because we both picked brownies, I'm going to subtract 1 from the top and from the bottom. If it were two different ones, like this situation with Eric and Sue, and I was picking brownies, you were picking cookies, we wouldn't subtract from the top. The only time we subtract from the top is if we have removed one of the possible outcomes. So again, 8 times 7 is going to give me 56. 12 times 11 is 121, I believe. Nope, 132. Whoops. And then I'm going to do 56 divided by 2 to get 28 on the top. 132 divided by 2 gives me 66 on the bottom. And I'm going to keep going by dividing by 2 again and get 14 over 33. And I don't think I can simplify from there, so we'll stop and get 14 over 33. If you have any questions, please feel free to reach out to me. Excuse me, I'm happy to help you any way that I can. Your job now is going to be to work on the independent practice. You do have that separately listed on the Google Classroom for you to work on. Like I said, if you have any questions, feel free to reach out to me. Make sure you've done a couple of practice problems before you move on to the Google Forms quiz. Hope to see you later. Bye.